Hi, this is Will Myers, and this is my video write-up of the system and how it works. So to start off, we'll go to the main Zool core loop. Initialization, I'm doing a very OO data-driven type system. A lot of managers, a lot of uh, very good upkeep, very good cleaning, very good management. So things I have a lot of managers. For example, the text, image, sprite batch, sprite man. So text hold textures, images hold images, sprite batch is the obviously the system to draw the sprites. Sprite man holds the actual sprite. The time man is a time manager that I use for callback systems, essentially to pull off the command pattern by using time events. Here we have the game object manager and the physics manager. Obviously, game object manager hold game objects, and physics manager hold physics objects. So here I set up the camera. We'll go through some class diagrams as well in a second. But uh, but in the update loop, so load is just does the load, which the load loads the textures, and then loads the images, which will be used for any level. Then here I go to my level manager, which let's find that diagram. Yeah. So the level manager is pretty simple. That I put all the data, all the data from a level, like for example AB level 1 and AB level 1 and level 9. I like okay, we'll take a look. So here's all the level 1-9 initialization, just nicely packed into one class, one header file, and then here's for level 1. I do this for all the levels. From there, AB level 1, show code, just has the load button, which calls the load, which calls each of those individual load sprites, load. Uh, let's find it. So the load just literally calls this line, for example, level 1, which creates the batches associated for this level, the sprites, the blocks, and the pigs. Very simple, very nice, very clean. Um, After that, the level manager, it has an active one that it walks through, so I set the active level, which the active level here is level 1-9. I just have that defaulted. And then the nice thing is I could do a nice little switch on the 1, 2, 3, 4, and 5 buttons, because you can load a level. Just all you have to do is just change what the active level enum is. Riley, shh. Active level enum is, and then you just call it load, load on it, and it loads just nicely. I'll show, like for example, you just grab the level that you want, and then call load on it, and it loads up nicely. After that, I guess the next thing to show off would be the slingshot. So the slingshot is a singleton. It holds the birds and launches the birds. It keep tracks if the active bird is dead or alive. The bird will delete itself, but this one is just where I store all the birds that are waiting to be queued off. And it's a nice little thing. This is where the logic for see if the drag was working, because it'll see if the active bird, if you're clicking on the active bird, it touches the slingshot as are you on the active bird, then you drag and launch. So the slingshot is a nice little. It kind of felt that it needed to be a singleton because you need one stop shop to know where the bird's loaded and what's up next. So for example, the fire method is that it grabs the bird, since I'm doing this through polymorphism that all the birds are the green bird, yellow bird's base class is bird. I grab the first bird out of the list. I find its center. I do the drag, and then I launch it. I also readjust the slingshot slings, but it's a nice little thing, and it worked out really nicely. So when the next bird gets loaded up, because all the stuff in here just refers to the base type bird, not any bird in general, which is nice. And then any special logic is kicked to the actual bird class, like the green bird activates its own ability. So that's the base of the slingshot. Here we have main update loop that's pretty lean, which I like. You have the world step, which the world step talks to the physics for it. Let me bring, where's that diagram? Okay. So the world steps, which the world pushes uh, all the information to the physics object, which the physics object in turn will uh, push the data to its game object. So so after the world step, you start here the physics object. Well, the world will talk to any physics object through the void pointer it has. Through the contact listener, for example, would be like updating anything that it happens to do, or just says its stats in general. So the physics object gets updated, which then the physics man walks through, which goes to each physics object, and the physics object has a reference to a game object. And then it goes to its game object, pushes all the data, for example, position and rotation. Then the game object walks, checks to see if anybody's alive or dead, puts it into, if it's dead, it marks it for death and we'll clean it up later. Then after that, it pushes all the information to Sprite, which Sprite then in the draw is correct and uh, in the correct position, the correct rotation, and whether or not it's alive. Time Man here is for the callback system, which we'll get to in a second. The process for the slingshot is just the check to see if the bird is essentially dead. That after, did you fire, and the bird that you have active on the list, if the bird's state flipped to dead, then remove the bird and load in the next one. Then here you see is that this is for just essentially cleanup side the world process, but cleanup goes in and cleans up all the dead bodies that I wanted that were marked for death, and Sprite Batch does the same thing, like for particles, for example, cleans up any dead particles. Uh, this is for the camera panning system. I still have to play around with it. It's not. It works pretty good. There's a couple things I want to fix up on it, but camera pan works pretty nice. Uh, and essentially it just tracks the bird when it's moving across. Now the thing I want to keep playing with is when to turn off the panning when you're dragging the screen and turning off. It's trying to get that state working nicely is kind of, it's a little interesting, a little difficult. And then for here we have the Sprite Batch Manager process, which works just as we were given. It walks through all the sprites and draws them. So this is the game object. This is pretty much what drives the game, is this diagram right here, is that the world pushes to physics, physics pushes the game object pushes the sprite. And if there's any other specialty, like whether or not game object's dead, they'll mark it for death and clean it up later. I wanted that association that the cleanup doesn't happen while it's being updated. I had some problems doing that, and it just makes it a little nicer if you just separate the problem so it's easier to deal with. Alright, other things to look at that I'm happy about is that, one, I'm doing super polymorphism. So for example here, the fat stone bar, like the smaller glass box, is type glass box, which is type block, which is type game object, which is a visitor, which I'm not using here, but it's there anyway if I need it. And then it's a man link, which the man link means that it's put on some type of manager. For example, in this, it's on the game object manager list. So I've gone pretty deep with the polymorphism, which works nice. For example, that all the blocks has its own emitter, which gets overloaded in the derived class. It all has different health images. It all has different sound. So I mean, it might not be. I mean, this is kind of what I was feeling right. I mean, it works. It still probably needs some iteration, but the nice thing is that I can kick all the stuff that every block has in common. I kick it as high up as I can. So all blocks have a spawn shards. All blocks have a create body, and it all has the similar states, whether it's full health, damage, state 1, 2, 3, or dead. And it works pretty nice. So after that, then you have blocks, which then right here we have type glass box, which glass box just has a Yeah, there we go. Which in the glass box, I actually overload the shard emitter that was in the base class, which with glass shards, and I give it the correct sounds. And I do the check health here for glass since all the glasses have similar health. And then finally, you get down to the very bottom, which is just the glass box, which is essentially it's just the update and any specific stuff that deals with this particular small glass box. For example, the images that it will cycle through. And I do this similar with the birds as well. So, for example, birds. The birds derive from a long list of. And the nice thing, I wanted to point out, just like in this one, from these three on the bottom are concrete. Everything above is abstract. You cannot initialize any of these, so that's nice. So I can't get in trouble. Also, pretty cool. We went through. Oh, this is just a little bit for the particle emitter. The particles, the emitter just does what it sounds. It just spawns. You just give it a name, coordinates, velocity. Is it a sensor, for example? Does it collide with other stuff, or is it just for particle sake? That just spawns like feathers. Or I use particles for both like spawning feathers and the poof rings, and also as the explosion things as well. Other stuff, the particle itself has its own crate body, which crate body, if it's a sensor, it'll just so I let the nice thing is I let even if it doesn't collide with anything or interact with anything, if it's a sensor, it's the physics engine still drives the simulation of the particles, which is nice. So I don't have to do one myself or get it in line with my system. So I just have all the physics do all physics things, whether or not it's actually a collidable object or not. So that also works pretty well. I kick the can to the physics engine to do the work for me. The only other one cool I did was a command pattern for the callback system. So for example, we have the pig explosion and the bird jump explosion. We have the base class, which is command, which command has a execute method. That's all it is, abstract. And then the bird jump overrides this execute method, for example, and it has a reference to a bird. It's very small. So it has a reference to a bird, give it a count on when it's going to execute, and then the bird method just calls a bird and the actual on the bird that you store into here, and then call the callback method, which then here, as you can see, because here if it's still in the waiting mode that it hasn't been fired or is in the sling, it'll apply a little jump, put itself back on the timer at a random interval, and put itself back on the timer, and then it'll get executed again later on, as long as it's still in the waiting state. So I was really proud of pulling this off with the command pattern, because it's actually using the timer we've been using. I just created a thing called time event, which time event takes a delta when it's going to go off and a command. And then commands an abstract class, so we have pig, I have a lot of commands. I just did 2 here. So anything for like the explosion for the blackbird, the pig explosion, the bird jump, the bird chirping, the pig grunting, all the things that take at a random interval or needs a timer, I'm using this, which is nice. It looks really good and really clean. So I'm running around out of time on my screencast-o-matic, so we went through just about everything. I'm really proud of how the system turned out, and it was a great project. Taught me a lot of things, and even more on where I want to take this engine further in the future. Thank you, and this is my Angry Birds write-up.